In our last video, we have learned the evolution of linear equations and how the Chinese mathematicians solved them. So in this video, we will start from the system of linear equations with some examples. Okay. So let me take an example first. Okay. Then we will solve the system of equations with our previous system. Okay. And try to analyze some more important things. Let us consider this system of linear equation. Okay, so according to our last lecture, we can write the system of linear equation like this. Okay, I mean Chinese mathematicians solve this linear equation like this. They just ignore the variables x, y, and z and write this in this form. Okay, and to solve this, what we will do is just first of all, we want to eliminate this and this using this one. Okay, so just so as this is 2, so what we will do, we will just multiply -1, then we will subtract it from the second one. So let me do it, and ultimately let us see the result. What we did here is the new R2 will be, we will just subtract this one at 1 row 1 by row 2. Okay, and we will end up with this, and we will subtract, we will multiply 6 for 3 minus 3 and then subtract it from the third row. We will have this. Okay, now let's see the next step. As this is negative, so we can multiply it by -1 and this all will be positive. Okay, so what we can do, multiply it by -1. Okay, so this will be this one, all the signs will be positive. Okay, now we just, the new R3 will be, we will just multiply it by -3 and add with it. Okay, so this will be 0 0 0. Our intention is to make this 0, but to make this 0, ultimately all the terms of the last row became 0. So this is an interesting formation, because the way we solve this is like this. I mean, we just 0 into x, 0 into y, 0 plus 0 into z equal to 0. Okay, and from this 0 into x equal to 0, and ultimately we will end up with 2y plus 6z equal to 2, and this, from this one we can have 2x plus 3y plus 8z equal to 6. All are value relations, and one thing that we can see from here is that this is 0 equal to 0, and one thing we can again, y equal to 3z equal to 2, we just make 2 common and cancel out it. Okay, so this thing we have. So now we don't have the solution, we don't get the solution from this method. So is the one question that naturally comes to our mind, that is this method right at all, or I mean, otherwise why you are not getting the solution of the system of equation? Okay, this is a natural question that comes to our mind, but before that, let's try to analyze by our rigorous method that is this solution, I mean, is this system has solution. I mean, how can you find the solution? Just our known methods, let's try to analyze it. Okay. So I will request everybody to go through our normal process. Still you will have this same relation. Okay, maybe the other relation but in the same form. You will not have a particular solution. This, you will definitely have this kind of form. You never able to find a particular solution for it. Okay, this kind of abstract form you will have. Okay, so now our motivation is that is the what is, then what will be the solution of this system of equations. Okay, so let me just try to uh, put the values of x and y so that these two relations became true. This is a obvious statement. We don't know this relation will always hold, but let's try to take some value so that these two relations become true. So let me take x equal to 3 by 2. Okay, and sorry, let me take z equal to 0. If z equal to 0, then from this relation we have y equal to 1, and from this relation if I put z equal to 0, y equal to 1, that's mean this is going to be 3 by 2. Okay, so now let me check for these values of x, y, and z, the two relations satisfy. So let me put these values. Let me see that these values for x and y is this system of linear equations satisfy or not. So we have this. So just put z equal to 0 for first case and y equal to 1. Okay, that's mean uh, 3 by 2, that's mean 3, and plus y equal to 1 mean 3. This is going to be 6 and z equal to 0. So satisfy for this for first case. Now second one, z equal to 0, y equal to 1 and x equal to 3 plus 1, that's mean 4. For second case this is also satisfied. Now for third case, third one, z equal to 0, 6, so this is going to be x equal to 3 by 2. If we put, that's mean 2 cancel out, then 3, that's mean 9, and y, z equal to 0 and y equal to 1, that's mean 8. Still that's mean for these values of x, y and z, these equations satisfy system equation. Now let me take, so just, so now let us take y equal to 0. If y equal to 0, that's mean z equal to 1 by 3, and what will be the value of x? X equal to, x will be 5 by 3. You just calculate, I calculated it and just put the value here. So now the values of, in this, for this case, the values of, we have the x equal to 5 by 3, y equal to 0, and z equal to 1 by 3. Now let's try to match them. So y equal to 0, x equal to 5 by 3. Okay, that's means 5 by 3, that's mean 10 by 3, and y equal to 0, z equal to 8 by 3. Okay, so 3, ultimately this is going to be 19. Okay, in this case we are not, maybe we made any calculation mistake, so let's me check once more time. Everything is right, just I made a mistake here. So this is going to be 6. Okay, so now for this case, and now this is for this case, this will be, just put the value here, 10 by 3 plus 0 plus 2 by 3, that's mean 12 by 3, that's in 4. And similarly for this case, 30 by 3 plus 0 minus 6 by, that's mean 6 by 3, that's mean this is going to be, that's mean 6 by 3, that's mean 2. Okay, and this is 10 minus 2, this is 8. So for this values, the system equations satisfy. And if you take any other value that will satisfy these two relations, okay, the system of equation will be satisfied. You can check, I only check for the two values of x, y and z. If you take any other values, the values which are satisfying these two relations, okay, so you will have find that this relation will satisfy. Okay, this system of linear equation will be satisfied. So one conclusion we can draw, that this system definitely has infinitely many solutions. Okay, because these relations are true for a lot of values of x. I can take any value, I can fix any value x, y, z, let's say 1, 2, 3, 1.2, 1.3, 1.3, any value, and we can find the values of x, y and z. Okay, so we can able to find that for any values of this relation will satisfy. So let me take one more example. Okay, let me write the example. I already did all the operations, so let me take this one, this example. That's mean x plus y plus z equal to 2, 2x plus 2y plus 2z equal to 5, 3x minus y plus 2z equal to 1. This is the system of equation and this is the form. So I just multiply minus 2 and then subtract it, and then multiply minus 3, then subtract it, and ultimately we end up with this. And this is an interesting thing, because we first, from the first one we have the relation x plus y plus z equal to 2, and the second one we have the relation that this z equal to 1, that means 0 equal to 1, which is not possible. Okay, from third case we don't even have to look at the third one, sorry, y and minus z equal to minus 5, so this is not possible. Okay, so we can conclude, because if in this form, you also, if I see that, if I multiply this one with 2, multiply the first equation with 2 and then subtract it from it, so that's when you will have that 2x plus 2y plus 2z, okay, minus 2x plus 2y minus 2 is minus 2z equal to 4 minus 5. That's mean this one cancel out, h1 everyone will be cancel out, and we will ultimately we have 0 equal to -1. This is an impossible result if you just look at it, if you just solve it by the natural process. Okay, that's mean this process is not wrong. Okay, in our in our natural process, what we know from our childhood, this is also giving a contradiction. So one thing we can say, that is this equation even have any solution? No, because this is a contradiction. We can't solve it, because this kind of, if I am doing I am doing some valid operations, and ultimately we are ending up with some invalid results. So we can say that this is, I mean, the actually the system is invalid. Okay, so in the last two examples, what we notice that for the first example we have infinitely many solutions in the first example, and in this second example we found that the system doesn't have any solution. Okay, invalid system. Okay, so these kind of questions where this kind of system of equations were arriving. Okay, and a simple question that would come to our mind, that why these things are happening, what is the solution of the system. Okay, so a lot of questions are coming. First question, definitely, what is the solution of the question, what is the solution of these systems. Second is, if the system doesn't have any solution, or maybe this has infinitely many solutions. If I consider that this system has infinitely many solutions, first one, and this has no solution, if we consider it, then why this is happening? For a system we having a particular solution. Okay, for any system we have infinitely many solution, for a system we are having doesn't even having any solution. So what actually happening inside the system? Okay, and one more question that is coming, that if this is not then what will be the solution of the system? Okay, is there really not possible, if it is not possible to find any solution of these systems? The second question, the answer of the second question is bit difficult, I would say. I mean, in the deeper linear algebra course you definitely will have the solution, answer. But the first answer, the what actually happening to these systems, this is very much important to understand. So we will try to decode it in this video as soon as possible. Okay, so but I will not decode it fully in this video. I will just try to tell you the process, the evolution, how the evolution happened. Okay, in ancient China these kind of systems were arriving, but they just ignored them. Okay, but gradually one of the most important branch of mathematics were arriving, developing. Okay, that is the geometry. Okay, the evolution of 2D and 3D geometry actually shows us the path of the answer of these questions. Okay, what actually happened when geometry was developing? Okay, mathematicians noticed that the equation of a line, okay, is just like, let's say, the equation of the line is just like the system of a linear equation. Just like, let's say, if we have 2x plus 3y equal to 6 and x plus y equal to 1. Okay, mathematicians show that this is the system of linear equations. Okay, and interestingly, this is the same thing, equation of a line. This is the same equation of a line. Okay, so the equation of the line is, the equation of the line is this, and the equation of this line is this. And mathematicians noticed that the solution of this system is x equal to 1 minus y, and we will have to put, if we put this value of x here, to 1 minus y plus 3y equal to 6. Okay, so ultimately y is equal to 4 and x equal to 1 minus 4, that's minus 3. Interestingly, mathematicians saw that actually this is the same point where the two line segments are intersecting. This one, this is also minus 3 comma 4 point. The mathematicians noticed this, and that's mean one thing that came to their mind is that's mean that actually finding the solution means finding the intersecting point in geometrically finding the intersecting point. Okay, so now, and this concept, this idea actually solved the whole mystery of a system of equations of not finding a solution or having infinitely many solutions. So what is how, let's see. they noticed that this system of linear equation doesn't have any solution. Okay, they noticed that in their in our conventional method. Okay, and in geometrically they noticed that these two are parallel lines, they never meet each other. That's parallel line never meet each other, so they have no intersection. So naturally a question comes to our mind is that in the for the unique solution, the two lines were meeting each other, and that meeting point, the intersection point, was the solution of the system of equation. And for a system where the system doesn't have any solution, for this case the two lines are not intersecting. Okay, that's mean the can you see how everything is matching. Now let me take one more example. Let's say this one. Okay, 6, and let's say 4x plus 6y equal to 12, and they noticed that this system has infinitely many solutions. Okay, they noticed that this system has infinitely many solutions, and they noticed that's mean what should be the graph of these two lines. As this is infinitely many solutions, then according to the above two examples we can say that that's mean these two line segment definitely intersect each other infinitely many times. But how a two line segments can intersect each other infinitely many times? Exactly, they are not different lines. These two are the same line segments. Okay, actually we can derive it also. We can just take 2 common from it. 2x plus 3y, that will be 6. These are the two same line segments. And from where actually the whole picture of having infinitely many solution and having no solution and having one unique solution became clear. But this is through 2D. Ancient peoples just extend the same concept for 3D. When the 3D geometry arrives, they saw the same thing. We have a plane. I cannot draw because drawing a plane is a bit difficult. But still, if I try to draw, okay, for unique solution, that's mean two planes. Okay, unique solution, that means three planes are there. Okay, three. I mean, if I have this thing, okay, for the previous one, let me write it. We saw that this has no solution, so that's mean they noticed that okay, these two planes are parallel planes. Okay, that's mean these two planes, let's say this one is one plane and this hand is another plane. These are the two parallel planes, and the third plane actually intersecting the two planes. That's mean like this. Can you see it? Okay, like this. Okay, this plane is intersecting two planes, but as there is no common intersection point. Okay, let's say like this, they intersect each other. Okay, as there is no common intersection point of the three planes, so this has no solution. Okay, you can see this is a plane which is intersecting this one, and this is a plane which is intersecting this one, but they don't have any common point of intersection. Okay, so we can say that this has no solution because they have no common point of intersection. And for infinitely many solutions, okay, for infinitely many solutions, what was the equation? This is the system of equation, and for this case there are infinitely many solutions. Actually these two planes, the last two planes, are not intersect. If you read the chapter plane in 3 dimension, you can plot in graph in Desmos 3D graph, and you can see that this is happening. These two planes are the last two planes are uh, actually let's say this is a plane. Okay, this is a plane, and these two planes are actually intersecting each other. Let's say these are the two planes, these are the two planes. Okay, this one and this is the plane which actually intersecting it. Okay, and the third plane, this one, actually going through the same intersection point. You can see the intersection of my hands. Okay, these are the two planes, and the third plane actually going through exactly through the intersection point. Okay, exactly through the intersection point. Okay, so that's mean the intersection is a line. So this the each point lying in the line. Okay, this is the solution of the system of equation. So for this, the intersection is the line. This is the intersection. Can you see this intersection? And the third plane is going through this intersection point. Okay, going through this intersection point. So the each plane actually intersecting my hand, intersecting each plane actually intersecting a single line. That means each point lying in the single line is the solution of the system. Okay, for this the system has infinitely many solutions. So now from here two questions may arrive. Okay, and the two same questions are arrived in mathematicians also. That first one, if we take any system of equation with four variables, okay, I can just add one more variable here. Okay, just let's say x, y, z, and let's say q plus, let's say plus q, q, and let's say this is 1 2 3, and I wrote one more, let's say equation equal to 4. Okay, if this happens, for this case what will be the picture, what is actually happening? That means the concept of 4D arrived here. Okay, so we cannot draw the picture, we cannot see the drawing, but we can visualize that actually what is happening in this kit. You can also visualize this. I mean, I will try to say it in my next video. And one thing, and again, geometrically this thing is happening, but actually geometry, but what is actually algebraically what is happening, can't we explain it just by observing it? Because if we have 4D this kind of things, then we have no way to draw the picture or visualize it. So how can you say that this has infinitely many solutions or no unique solution or no solution? How can you say this system has infinitely many solutions? Because we cannot draw the system, we cannot visualize it. How can you say? So this, then the question that comes to our mind here is that we need to do the whole thing algebraically also. We need to explain all the thing, why the system has unique solution, why a system has infinitely many solution, and why a system doesn't have even a solution. Okay, so we need to explain it algebraically. We able to understand it? I think I able to explain you how a system has infinitely many solution, it's a unique solution and no solution geometrically, but we need to understand it algebraically. Because for a 4D, let's say I add one more variable here, we cannot say, thus we cannot draw the picture. So how can you say that this has solution, unique solution or infinitely many solution, or no, or not even a solution? So we need algebraic approach. In our last video, in our in our next videos, we definitely try to analyze it algebraically. Okay, so for this, for all today's video, I think you guys able to understand what I tried to tell you. Thank you.